Hello and welcome to Grace Tutorial. In this video lecture, we will be discussing about one of the most important parts of the aliphatic amines, that is all about the basicity of amines. And here in this part, I will be explaining you a very clear understanding whether the amines show the basic nature or not. Let's have a look. If you look at ammonia, that is NH3, this nitrogen of this ammonia consists of a lone pair of the electrons. So how is it written basically? So due to the presence of the lone pair of the electrons of the nitrogen atom, here this ammonia, it acts as a base. Similarly, the basicity of the amines can also be explained. That means the amines are also basic in nature, just like ammonia. Because if you will write the general formula of amine, that is RNH2. So here this nitrogen consists of the lone pair of the electrons. That means this lone pair of the electron, and due to the presence of the lone pair of the electrons over the nitrogen atom here in the amine, this amine also acts as the base. But something, the basic nature of the amine is also linked to the structure of it, because the nitrogen atom here is sp3 hybridized. sp3 hybridized, wherein it has the 25% S character. But let us try to understand that how can we explain the basic nature of the amine. I have said that just like ammonia, how it is a base, similarly the amine is also a base due to the presence of the lone pair of the electrons. But on which factors the basic nature of this amine can be explained? Let us try to understand in a very clear-cut manner. Suppose what I have amine RNH2, and when this reacts with HCl, that is hydrochloric acid, it gives NH3 plus Cl minus. Why? Because if you will dissociate this HCl, you will get H plus and Cl minus. So this H plus, it reacts with, it comes under this part, RNH2. Here H2 is there and one more H is added, right? Now RNH3. So what happened here? Here the lone pair which is present in here this nitrogen atom, this lone pair is available for the proton attack. That means the protonation takes place, and as a result this proton, the H plus, it attacks the lone pair of the electrons where the nitrogen atom possesses. That means when the lone pair of the nitrogen atom is attacked by a proton, and that finally will be changed into RNH3. Since it loses the electrons, that's why a positive charge is created here, and this is Cl minus, so RNH3 Cl minus. Similarly, if you will look, if this amine is reacted with a water, then what happens? Exactly the same thing happens, but RNH3 plus this is OH minus, and again we can write that Rn plus H3 plus OH minus. But what is the equilibrium constant? If you write the equilibrium constant, that is Kb equal to the molar concentration of RNH3 plus OH minus divided by the molar concentration of amine and water. And it also can be written R NH3 molar concentration and molar concentration of OH minus divided by R NH2. Yeah. So what we need to understand here, more the number of equilibrium constant, that is Kb, higher the value of the Kb, higher the value of Kb or lower the value of pKb. pKb means minus log Kb. Stronger is the amine. So if you write the equilibrium constant, this is the equilibrium constant, we have written the Kb, but higher the value of Kb or lower, higher the value of Kb or lower the value of pKb, that is pKb is equal to minus log Kb, then stronger is the amine. So if Kb is higher and if pKb is lower, then amine will be the stronger one. So according to the equilibrium constant, it can be explained so way, but we need to try to understand something it very differently, that the basic nature, the amines show the basicity, that means it shows the basicity in character. This is basic in nature, amine is basic in nature, but the basicity of the amine can be explained in some different factors. So what are those factors? Let us look at some of the important factors. So the first factor that I have is inductive effect. So according to this effect, inductive effect, more the number of alkyl groups, greater is the basicity. So what does according to inductive effect say? More the number of alkyl groups. The alkyl groups we write are, which is the electron releasing group. So what according to inductive effect says that more the number of electron releasing group or the alkyl group, then greater is its basicity. So according to this concept and according to this definition, what is the order of the basicity of amines? The order of basicity of amines is that R3N, that is the tri-tertiary amine, is greater than primary amine, and that is also greater than tertiary is greater than secondary, secondary is greater than primary. That means if you look at the basicity of this amine, the tertiary amine is more basic than secondary, secondary amine is more basic than primary. That means the tertiary amine is the most basic and the primary amine is the least basic, according to the definition of this inductive effect. So what does the inductive effect says that when the electron releasing group or alkyl group, it increases, then the basicity, the basic nature of that amine also increases. And due to the availability of the lone pair of the electrons on the nitrogen atom, and this nitrogen atom, the lone pair of the electron which is available over this nitrogen atom, this will be available for the protonation, available for protonation or proton attack. And this is the reason why these are basic in nature. And this lone pair of the electron which is there in the nitrogen atom, this will be available for the proton attack. That means the proton can attack over that lone pair of the electrons of the nitrogen atom. Since the proton will be attacked, since the proton can attack the lone pair of the electrons over the nitrogen atom, that's why this is basic in nature. But this basic nature can be explained according to the way of inductive effect. So the inductive effect says that more the number of alkyl groups or greater is, more the number of electron releasing groups, then greater is its basicity. So according to this definition, the order of the basicity of amines according to the decreasing order is that tertiary is greater than secondary, secondary is greater than primary. But what is actually the correct order? The correct order in the aqueous solution, the order of amines, the decreasing order of amines in the aqueous solution. The decreasing order of amines in the aqueous solution is that secondary is greater than primary, primary is greater than tertiary. This is actually the actual order of the basicity of the amines. That means the secondary amine is greater than the primary amine is greater than the tertiary amine in case of the basicity, in case of the basic character. So which one is the more basic? The secondary amine. Which one is the least basic? The tertiary amine. But how it can be explained? According to the inductive effect, here the decreasing order of the basicity of the amine is represented so way. But the actual order of decreasing order of amines in the aqueous solution is this one. So this also can be explained. Let us move on to another factor, that is steric factor or steric effect. Let us try to understand, my dear students, what does the steric effect says that? Suppose I have the methylamine. Methylamine and trimethylamine. So if you will compare the basicity of the methylamine and trimethylamine, which one is more basic? According to the steric effect, the methylamine is more basic than trimethylamine. That means the trimethylamine is the least basic and methylamine is more basic than that of trimethylamine, according to the steric effect. But how? What does the steric effect say about the basicity of the amine? The steric effect says that if you look at the trimethylamine, here the trimethylamine means you have 3 alkyl groups. Since you have the 3 methyl groups, the alkyl groups are basically bulkier in nature. They are bulky in nature. Alkyl groups are basically bulky in nature. Since these are bulkier in nature, these groups hinders the proton attack. What does it do? It hinders the proton attack. So the lone pair of the electrons which is present in the nitrogen atom of this trimethyl amine is not so much will be available for the proton attack. But if you look at methylamine, here also it consists of the lone pair of the electrons. But here this lone pair of the electrons will be easily available for the proton attack, because here it consists of only one alkyl group, that is only one bulkier group. And since due to the presence of the 3 alkyl groups, the 3 bulkier groups, that's why these bulkier groups, it hinders the proton attack, so that there is no chances of getting completely attacked, proton attack takes place. here in case of the trimethylamine. That's why the methylamine is more basic than that of the trimethylamine. So that is what all about said by the steric effect. Now we need to understand one more effect, that is about solvation ion effect. So you have understood the inductive effect, and according to the inductive effect, what is the order? You have understood the steric effect, and according to the steric effect, which one is more basic, either methylamine or trimethylamine. Now we look at the solvation ion effect. So if we look at the solvation ion effect, what is this effect says? Suppose you have amine. When this amine is dissolved in water, then you will get RNH3 plus OH minus. When the primary amine is dissolved in water, you will get this one. Similarly, when the secondary amine is dissolved in water, it is R2NH plus water. R2N plus OH minus. Similarly, when tertiary amine is dissolved in water, then you will get R3N plus H plus OH minus. So this is what actually the products are obtained when the primary amine dissolved in water, when the secondary amine dissolves in water, when tertiary amine dissolves in water. But what we need to understand here, when that amine dissolves in the water, then let me write one here. So RNH3 plus this one, and when this primary amine dissolves in water, then it reacts with the hydrogen atom, it reacts with the water molecule and forms the hydrogen bonding. In this way, the hydrogen bonding takes place, and greater the number of hydrogen bonding, stronger its basicity. So here the maximum hydration takes place. So if you look at number 2, that is R2NH. Here what happened? Here also it reacts with the water molecule, but here the hydration takes place. The hydration energy is released, but the more hydration energy is released in this case of the primary, but the less hydration energy is released in case of the secondary. Less hydration. Suppose let me take this one hydrogen is there with us. So this is the least hydration. So look at here, it's very simple to understand, my dear students. When the primary amine gets dissolved in water, then the hydrogen bonding takes place between the hydrogen atom of the amine along with the oxygen atom of the water molecule. The hydrogen bonding takes place, and during the process of the hydrogen bonding, the hydration energy gets released, and more the number of hydration energy gets released, the maximum will be its hydration 10. So in which case the maximum hydration has been taken place? That's in case of the primary amine. That means here it is RNH2, or we can write that RNH is greater than R2 NH2, that is also greater than R3 NH plus. So this is the order according to the solvation ion effect. So if you look at the entire all the effects from the combined effects of the inductive effect and steric effect as well as the solvation ion effect, what did we observe here? The secondary amine is the strongest base. The secondary amine is the strongest base. Then after primary, then we have tertiary. So this is actually the order. The secondary amine is more basic than primary, and the primary amine is more basic than tertiary. And these three things can be, the basic nature of these amines and the order of the basicity of this amine can be explained on the three factors like inductive effect, steric effect, and the solvation ion effect. So this is all about, these are the different factors, and these factors definitely will help you to get an understanding that what is the actual order, what is the correct order, what is the proper order of the basicity of the amines. That means what we all have discussed here, amines show the basic in nature. Of course, no doubt, due to the presence of the lone pair of the electrons over the nitrogen atom, and that will be available for the proton attack. Since the lone pair of the electron in the nitrogen atom is available for the proton attack or for the protonation, and that's the cause, that is the reason why it acts as a base in nature. But we need to understand that, amines, there are three types of amines: primary amine, secondary amine, tertiary amine. Which one is more basic or which one is the least basic? And in order to understand the order of the basicity, I have explained you the three different factors. One is the inductive effect, another is steric effect, and the last one, the solvation ion effect. And from all these combined effects, here it has been observed that the secondary amine is the strongest one. That means that is the strongest base. Similarly, the tertiary here the tertiary is, the tertiary is the least, or it is the lowest base. So this is what all that we need to understand from the basicity of amines. I hope the basicity of amines is very clear to you, and if you are having any doubt regarding to the basicity of amines, you can put it there in the comment section, so that I'll try my level best to make you very much clear. So that's all about the basicity of amines. Anyway, thank you very much for watching, and if you would like to go for the next part of the video lecture, I would request you to press the bell icon over here to get the latest notification. Thank you very much for watching.